Kia ora and welcome to this refresher training, this recap on Mitre saw safety. This is not supposed to be a full training video. This is based on the assumption that you have completed the training at Kahoot's workshop. And then this is a recap, a refresher to help prompt you about the things that you learned. This is a Mitre saw. This is a compound sliding Mitre saw. It slides backwards and forwards for making long, deep cuts on pieces of timber. It mitres in that direction, and it mitres in that direction. That's why it's a sliding compound mitre saw. The compound is the two mitres. Mitre saw is used for cross-cutting lengths of timber. So you have a length of timber and you cross-cut it. The saw can't cut steel, and so we need to be careful about screws, nails, staples, other bits of steel in the timber. We can't cut pieces of steel. You can cut some plastics, you can cut some aluminium extrusions. So those are things you need to check with the manufacturer of the material. Before we get started, there are a few things we need to do. We need to check the saw over. This saw bench is a little bit wobbly. We need this to be stable, whether we're cutting on a portable saw bench, whether we're cutting on the fixed Mitre saw that we have in the workshop, or whether we've got this on the floor on a job site. It needs to be stable because otherwise things move when we try to cut, and that way all kinds of unpleasant things can happen. I'm going to stabilize this saw bench. So I've adjusted the saw bench and now it's solid. We also want to check that the saw is locked firmly to this saw bench so that nothing moves. And then, because the saw is a Mitre saw, we want to check that the mitres are secure so that those aren't moving around during a cut. This is one mitre, and if I pop it in the 0 position and it's locked, it's very firm and it's stiff anyway, so it doesn't move around freely. The second mitre, this direction, those are often very loose, and we definitely don't want the saw to try and move while we're cutting, so we make sure that is secure too. Finally, we want to make sure that the guard retracts properly when we pull the saw down. We're not turning the saw on. In fact, at this point, we're doing checks. It's best to have the saw unplugged. You'll need to have it unplugged for the next step. So we pull this down and the blade guard retracts and the blade comes down into the area where the workpiece will be. Finally, we want to make sure that the blade is secure on the saw. So we can pull this guard back, and as I said, the saw is unplugged. Make sure the saw is unplugged for this step. We grab the blade and we give it a bit of a wiggle, and you can feel that it is firmly attached to the spindle. It doesn't move in that direction, and it moves this way with the motor, but it does not wobble at all. It is nice and tight. The nut on the end here, or the screw, depending on how it's fastened, is nice and tight. The teeth all look to be in decent condition. It doesn't matter if there are a few chipped teeth, but what you want to make sure is that there are no big cracks in the saw blade. This all looks good. I'm really happy to use this saw. So now that the saw is secure, we can start to think about some of the hazards that are always present with this machine. It's loud. We're in the workshop. It's an echoey space. We can't move the saw into a quiet area, so it's going to be loud and you're going to need hearing protection. There's a risk of entanglement, getting pulled into the blade, getting pulled into moving workpieces, so no baggy clothes, no long hair. Now obviously my hair's tied up, but, and so I'm going to put a hat on and tuck my hair away. You might tie it in a bun. These saws are dusty. They're always going to be dusty. We do have dust extraction. You make sure the dust extraction is connected to the saw and turned on, but that doesn't control all dust, so dust mask is going to work for that. Dust also gets in your eyes. And so we have eye protection. Also, in the case that wood splinters in some unexpected way, these are going to save your eyes. So now that we are set up, let's move to the other saw, the fixed saw that's in the workshop, and I will show you how to set up for a cut. So this is the saw that is built into the bench at the workshop. We're at a new saw. Let's do those checks. That mitre is secure. That mitre is secure. The saw is bolted to the bench. We don't really need to check that every time. The saw's unplugged and the blade looks good. When you're inspecting these blades, these teeth are sharp. Watch out for that. So I'm happy to use this saw, but there's one more hazard. There's a trip hazard down here on the floor. I'm going to move that out of the way. If using a saw like this, if using any tool, the likelihood of injury is going to increase if you're not stable, if you can't move around, if you trip and fall. If I'm using this saw and I'm doing everything right, but then I trip or I slip, I've then got a chance of getting my hand near the blade. There's also the possibility that someone turns up and makes me jump, that someone approaches me from behind, that I try to take a slight step backwards and I hit someone behind me. So when you're using a tool like this, you're in charge of this area around you. You need to look around, you need to see, is there anyone working near me? If there is, I can tell them what I'm doing, I can tell them to wear hearing protection, I can make sure that they are safe, and I can make sure that I'm safe by having an exclusion area around me. So let's talk about proper work holding. This is your workpiece. It's got 2 holes here. Did it have screws in? Probably. Is there anything in them now? I can see straight through the holes. The screws have been taken out, so I don't need to worry about cutting those. Proper work holding for miter saws, never cut timber like this. This timber is going to hit the moving blade and it's going to be flung back into that fence. It could trap your fingers, it can cause bruises, it can twist the timber and the timber can grab the blade. That's called binding or kickback. It will make the saw jump, but it will also make this timber move very violently. At that point the timber can crack, and if it cracks, pieces can fly off. This is just a dangerous situation that we don't want to get into. So the most important thing about placing timber to cut in a miter saw is that it is flat on the base plate and it is hard up against the fences. If you're cutting a short piece of wood that can move more easily, that doesn't properly span these fences, then there's a clamp you can use to hold that timber in place. It can't move, and I don't need to hold it in place. Don't need to rely on myself, and it's stable. Long pieces of timber, like this, or even longer, are inherently very stable in a miter saw because of the long fence, and we have an extended fence on this saw. And so this piece of timber is not going to move very much, but you do see there's a little bit of a twist in it, and it rocks slightly. One thing we could do is turn it around, and it still has a little bit of a wobble. That's not too much of a problem, but it does increase the risk of the blade binding. So we've got to think about, where will the blade push the timber if it binds? Well, if the blade's pushing here, the timber doesn't go anywhere. So if the blade binds a bit, the timber cannot fly out, it can't go up and back. If I was cutting this piece of timber and let's say, oh, I want it a little bit higher, and I grab another piece of timber and I put these together and I sit that one there and that one on top, then suddenly it's unstable. So we never cut multiple pieces together. See, this piece of timber is not bound by the fence, so if we try and cut it like that, saw comes down, hits this piece, and it flies away. So we never cut multiple pieces together. That's called gang cutting. We don't do that. Never cut freehand, never feed wood into the blade. That would be setting the blade here and then bringing the timber into the blade away from the fences. Again, it's really an extension of the same safety rule. The workpiece needs to be hard against the base, hard against the fence. That's how we cut. No cutting like this, making long rips. This is not the right tool to make rips in pieces of timber. That's with the grain down the length of the timber. This is unstable. This will bind. There's not much fence here preventing it from going up and back. You'll probably break the saw and you might really injure yourself. If you're holding this, your fingers can get dragged into the saw. You can get bruises, breaks, fractures, and the timber can fracture and splinter, and you can get pieces in the eye, you can damage the saw blade. It's all too much like a bad day. So, now that we've got our workpiece properly positioned, and we've presumably measured it and marked where we want to cut, we can cut the piece. When we do, we're going to have one hand on the workpiece to hold it firmly back and down, this hand here, and we're going to make sure that that hand is nowhere near the line of the blade. When we bring the blade down, for small pieces of timber, we don't need to slide the tool. We can just bring the blade down, running, and all the way through and back up. For larger pieces of timber, we slide the blade forwards, we start at the front, we introduce the blade on the front top corner of the piece of wood, and then we push backwards once we're all the way down. That means the forces that the blade is exerting on the workpiece are down and back, so it's into the base plate and back into the fence, and that keeps everything stable and secure. We don't want to come down and then this way. If you're in the situation that you come down and you don't clear the workpiece, you can come back up, you can come forward, and you can go down and cut. I'm going to plug the saw in, I'm going to get my PPE on, and we're going to demonstrate that. Okay, so now the saw is plugged in. We're going to check that it's powered up. It is. We're going to turn on the light on this saw, which is going to tell us where the cut's going to be made. As we come down, we get a shadow on the piece of work that shows us where the saw is going to cut. Shadow of the blade. Some of the other saws have lasers to do the same thing. I like to think about hand positioning when I do these cuts. If I've got one hand in a very known place, pushing the workpiece into position, and the other hand on the handle, then there's no chance that my hand is near the spinning blade. So I'm going to make this cut now. And the thing that's very important there is to let the saw come up and the blade stop before I reach in and grab this. You can imagine if the blade is still spinning, it's hard for me to touch any exposed teeth, but it's not necessarily impossible. The guard takes a moment to close, so we just give it a moment, let everything calm down, make sure it's not running before we reach in and take the work pieces. We can do the same thing on our small piece. Remember, I've checked those holes for screws. Firmly hold the workpiece in place. We don't need to slide for this one. We'll just do a straight cut. Now what if you have workpiece that's sticking out the other way for some reason and you need to cut that? Well, one of the most dangerous things you can do is to cross your arms. If we cut like this, there is a very real risk of exposure of my arm to this blade. So this is a tool that you have to use right or left-handed depending on the side that you're cutting on. If you're cutting on this side, well then we'll secure with my right hand and I'll run the saw with my left. Now that feels weird to me because I'm right-handed, but the saw can't go anywhere. All I'm doing is pulling a trigger and moving the saw in a plane in which it's constrained. So I don't need dexterity. I don't need to be ambidextrous to make a good job of that with my left hand. And finally, let's look at the mitre functions on this saw, the adjustments there. This saw has a lock for this mitre. That's locked, you can feel it get tight. That's unlocked, but it still won't turn, and that's because this button here provides an index at various spots. Now that it's moving, I've let go of that button, but it's stayed depressed, and as I come back to the 0 position, that button will pop up and it locks into place. So certain positions, like 0 and 45 degrees, those are indexed. There's a reading here, tells you how many degrees you're cutting at. So you can move to any position, and then you can lock in place. Let's cut over there. So all the cutting processes are the same. We're going to secure, we're going to make sure that we're not in the way of the blade, and we're going to make that cut in the same fashion. Now, some of the forces of the blade are now at an angle to the workpiece. They're not directly down and back into the fence and the platen. So there's a little bit of potential for the saw to be gently pushing the wood this way. That means there's more risk of the blade binding. And so when you're cutting on mitres, you want to make sure that this is more secure. And the bigger the workpiece, the more important that is. With a small workpiece like this, I can secure it with my hand, but this is a time when it's a very good idea to use clamps. If this workpiece does push that way, it will twist a little, it will bind the blade that's now in the slot here, that it's in the kerf that it has cut. It will bind up and it will probably just stall the blade because it is a nicely mounted workpiece. But again, if there's any potential for it to move up and back, for it to kick out in that direction, it will, and then we've potentially got flying timber coming towards me. Again, making sure that your timber is hard down and hard back. Let's make that cut. Now I will show you the other mitre. The release on this saw is on the back in a slightly awkward place because of the way that our dust extraction works. I've got a gauge on this side which shows me the angle that I'm at, and I've got an adjustment to loosen and tighten. Now when you set up for these kind of cuts, you've got to be aware that things like this clamp here might be in the way. So you've got to check that the saw still has motion, which it doesn't, because that clamp's in the way. If we did need to make that cut, we could remove the clamp. If your workpiece is secure, binding is just going to strain the motor. You're going to hear the saw experiencing that friction. you're going to hear it making the motor work harder. You can check your work holding, make sure that everything's secure as it can be and the wood is not moving. Let's make this cut. And of course, the real reason that the saw does both of those motions is so that you can do both at the same time. And this is really not a very common thing to need to do. But if we do this, we now have a piece of timber that is cut at 2 angles. It's cut at one angle that way, and it's cut at one angle that way. It's good practice to reset the saw to its upright position and its centered position. If the precision of your cuts is important, then you can use a square to check that the blade is square to the platen and to the fence, but do turn the power off first because you'll be moving the guard and inspecting the blade. The final adjustment that these saws have is usually the ability to lock the slide. This one's a little nut there, and that means that if you're cutting lots of small pieces of timber, you can stop it from sliding, and you can just cut up and down and the saw won't slide. In theory, that makes the saw a little bit more precise if you need to make a lot of very accurate cuts, because whenever the slide moves, there's a little bit of potential for the saw to wobble, but it's honestly so small that most of the time we never bother to lock the slide off. And that's the Mitre saw. So hopefully that refresher was useful. Hopefully it reminded you of the things that you learned when you did this training. Remember, you're always very welcome to ask Kahoot staff or Kahoot volunteers who've been approved to train you on this for a refresher, for some more information. Otherwise, enjoy the workshop and make some cool things.